limitations to large language models.
Whether it is the training data cutoff date, lack of memory, hallucinations, or embedded biases in the responses, they need to be addressed. We see a tech stack emerging to fix these limitations and for streamlining app development with LLMs. This is a simplified view of the emerging LLM tech stack. Let's start from the bottom. Vector DBs. LLM models like GPT are stateless models. They do not maintain an internal state between different requests and inputs. Therefore, LLMs need an external mechanism to maintain the context in an interaction. This is where vector DBs like Pinecone, Elasticsearch Dense Vector Fields, PostgreSQL, pgvector will help. Embeddings are dense, high-dimensional vector representations that capture the semantic meaning of text. Vector databases, which store these embeddings, are particularly useful for conducting similarity or semantic searches. Above vector DBs, we have the model layer. This is where GPT or the open source LLMs like Alpaca or Llama reside. Orchestration layer serves as a high-level controller that manages the interactions with the model to create more effective and reliable applications. It can provide a range of capabilities and features to enhance the performance of the LLM and also better align its outputs with the goals of the application. Here are some of the things an orchestration layer can do. Prompt chaining, conversation management, bias mitigation, safety and content filtering, fine-tuning, temperature and top case sampling control, user personalization and integration with other services. We have emerging frameworks like Microsoft Semantic Kernel or open source LangChain that acts as lightweight SDKs at the orchestration layer. UI layer is a no-code dev environment where one can use a GUI to define function chains and develop coherent language applications in a no-code manner. Okay, what capabilities then do we look for in a language app? First of all, our app needs to be data aware. Language models like GPT are generalist models. We need to connect them to other sources of data to align semantic capabilities of the language models for each individual use case. Secondly, we expect the app to be modular, composed of a list of programmatic functions or skills that can turn into a structured sequence of calls or chains. This is almost like a predefined pipeline of calls to carry out a specific task requested by the input prompt. Next, we expect the language model to be agentic, to be able to interact with its environment. One challenge with developing with language models is that in order to be able to fully leverage model capabilities, we need to do prompt management, optimization, and serialization by ourselves. And agentic means the model can automate and implement these tasks by itself so that it has the ability to take actions, make decisions, and interact with its environment based on its understanding of inputs. This is like the early AGI-based attempts with the likes of Baby AGI and AutoGPT embedded into the application, planning and executing actions as per request by each prompt. And lastly, we need to have a capability to validate the responses of the language app. This is because the data already includes embedded biases and any hazardous or harmful response needs to be filtered. Okay, and with that, I hope I was able to give some perspective about the general requirements for developing applications with language models. In this series, I'm planning to adapt a learning by doing approach, and next in the series, we will develop an application where one would be able to query their data with Azure OpenAI. Stay tuned.